Hello math kids, my name is Ayanat and today we're going to be learning and discussing topics of 4th, 5th and 6th units. So my first question for you is how familiar are you with the previous 3 units? I recommend marking your understanding out of 5 stars. I will give you 10 seconds for that. Brilliant! Now let's move on to the first topic, which is going to be 4th unit. So today we're going to be discussing stretching and reflecting quadratic relations, 4th unit, similar triangles and trigonometry, 5th unit, and triangle trigonometry, 6th unit. So on this lesson, I'm going to explain you 3 topics of 3rd, 4th and 5th unit, explaining the goal, solving examples, learning goals, and testing your knowledge at the end of every unit. So make sure you spend maximum of your energy on that. Firstly, I want to start with about myself. So my name is Ayanat and I'm going to be your teacher for today. I'm 15 years old. I'm professor of math. I'm the best teacher in the world, obviously, and I have a bachelor's degree at Harvard. So now let's move on to our first topic. So the topic is stretching and reflecting on quadratic relations. So stretching or reflecting on quadratic relations involves altering the shape of a parabolic curve. Stretching a quadratic relation involves multiplying either the x or y term by a constant which elongates or compresses the curve vertically or horizontally. For instance, stretching a rubber band makes it longer or shorter depending on how much force is applied. Reflecting on the quadratic relation flips the curve either horizontally or vertically, like flipping a picture horizontally, changing its orientation. So these transformations allow vertical manipulation of quadratic relations to fit various real-world scenarios and mathematical problems. So here is the example with a rubber band. So stretching a rubber harder makes it longer or shorter depending on how much force is applied. So the main formulas you have to memorize in case you succeed are the 3 formulas of quadratic graph terms. So make some notes, guys. As long as I explain the topic and concept of those topics, I will provide and discuss examples. After we analyze them, I will give you discussion problems which you will have to analyze and solve personally. Okay, so let's move on to our examples. So example number 1, selecting a transformation start by graph to a graph parabola. By transforming the graph of y equal x squared. Describe how the graphs of y 3x squared are connected. So now let's move on to making our formulas. So firstly, we sketch our graph. Boom, and here it is. So now we gotta sketch our numbers. So let's move on by making formulas. Y equal x squared and y equal 3x squared. We're going to continue by filling the coordinates of a graph. Firstly, y equal x squared. So this is how it works. Basically, we choose a number from the x-axis and take 1. So 1 squared is 1, which means the coordinates of the first point are 1.1, which also refers to others. Boom, and we have created our first graph by doing the same thing with all the coordinates. So now let's do the following instructions to complement the second graph of y equal 3x squared. So let's take one from the x-axis and pull it into the place of x. Boom! And 1 squared multiplied by 3 is equal to 3. So that's how we get our first point, which is going to be 1 1/3. We do the same thing with number 2, and we get our second point. As a result, we sketch our graph, and this is how it basically looks. So now I'm going to give you a problem for you to solve. So you will have to do the same thing but with different formulas of graphs. You will have 10 seconds to complete this task. Well done, guys! So now let's move on to new topic. So Unit 5. Our second topic is similar triangles and trigonometry. Now let's move on to the fifth topic. Overall, this unit will discover topics of similar triangles and trigonometry. Mostly we will focus on using our knowledge of radio and proportion to investigate similar triangles and solve problems related to similarity and solve problems involving right angle triangles using the primarily trigonometric radius and the Pythagorean theorem. So, in triangles refers to the condition where two or more triangles have equal same size and shape. This implies that their corresponding sides and angles are equal. For instance, two triangles have all three-sided equal lengths. They are congruent by the side SSS, congruence creation. Similarly, in triangles implies that their corresponding angles are equal and their corresponding sides are proportional, though not necessarily equal in length. An example of similarity would be two triangles with all the three angles equal. So now I'm going to discuss traffic sign. So traffic sign is triangular road signs, often come in various sizes but maintain congruence in their shape. A small yield sign and a large yield sign will have the same shape with corresponding angles and side proportions, even though their sizes differ. So before going on to our example problems, you guys have to memorize this thing. It is called, what do you know about the symbol? In mathematics, this symbol known as prime, and usually we use it while solving problems. So this is how it is demonstrated. So our first example. So in this example, we will have to create a triangle that is similar but not congruent to ABC. Is ADEF similar to ABC? So first, we gotta do this example is to draw a triangle. I tried my best visualizing it right. So now we label the primes of every side and consequently multiply the sides. As a result, we get this number. So now we gotta divide sides of both triangles. Firstly, we divide AC by DE, and after doing that, CB and EF. That's how we get our numbers. So this is basically our answers. So now we're going to move on to our second example. And you're going to have 10 seconds for completing this problem. Well done, guys. Now let's move on to our third topic. So our third topic is triangle trigonometry, unit 6. In brief, the main topic of 6 unit is triangle trigonometry. We will face problems with the involvement acute triangles using the sine law and the cosine law. The topic we will be discussing in short but informative lesson is the sine law. It is a base of trigonometry and basically the foundation it cannot exist without. So what is the sine law? The sine law is also known as the law of sines, relates the side of triangles to the sines of its angles. It states that the ratio of the length of the side of a triangle to the sine of the angle opposite that the side is constant for all the sides. This mathematical principle is particularly useful in trigonometry for solving triangles when you have the lengths, some sides and their opposite angles. So, these are some everyday examples of the sine law. So, we can include determining the height of a tree or a building by measuring angles and distances from different vantage points, or calculating distances between invisible points using triangulation methods in navigation or surveying. So now, using the formula we were discussing to construct a triangle, try to follow this table using the sine law. So here, angle sine and length of opposite side divided by sine angle and demonstrated. So we are going to fill it up looking at this triangle. So do you remember the formula I have showed you? So this formula, we are going to use it for solving this problem. So firstly, we fill the table. A is equal to 78.1, B is equal to 48.2, C is equal to 53.7. As I told you before, guys, sides which are parallel to a given angle are connected. So 6.5 goes for A, C goes for C, and is equal to 5.4. And 5 goes to 48.2. So now, using all data we have collected, we use the formula length of the opposite side divided by sine angle. So this is how we basically did the first example. So it wasn't so hard, isn't it, guys? I think it's time for you to try to do your own example. I believe that was understandable for you. So now you gotta do an example yourself. That won't be hard, believe me. As usually, guys, giving you 10 seconds to think. Awesome! Well, that's the end of our lesson. If you have any questions, you may ask them under the video. So, these are the sources. And thank you for your attention. I wish you liked this lesson.